All right. Welcome back. Welcome back, everyone. I'm really excited to present Joaquim Verges. Was that close enough?
That's really close.
Okay. Joaquim is an Android fanatic working at Twitch. He's one of the organizers of the SF Android meetup. Before Twitch, he worked at Twitter, which I'm really thankful for the dark or night team. I love it. And then he's really big on design, performance, and also fast iterating on apps. He's very popular for like his indie projects. I would say his most famous one is Falcon, which is a Twitter client. My favorite one was Flying, which was an offline newsreader.
Really?
Yeah.
Okay.
I met Joaquim maybe a couple of years back, maybe in a meetup or some bar over SF. I think he's definitely one of the top Android developers out there, so I'm really excited to hear what he has to share on MVP and Kotlin. Let's hear it for Joaquim.
Thanks, Avelio. Hey, everyone. I'm Joaquim, and I'm really grateful to be here. Thank you for having me. This is pretty awesome. I love the setup. So as Avelio said, I work for Twitch, and I worked at Twitter before, but today I'm here on my own, actually, to talk about my latest little personal project. I'm more of a UI guy, personally. I love products. I love anything visual. But this project is a little bit different for me, and it's a first, so let me know what you think. But before I start getting into the actual project, I want to talk to you a little bit how I even came up with the idea for this thing. So, as I said, I love products. I love building apps. And I get a lot of ideas generally out there in the wild. And when I get an idea for an app, I get really, really excited. This is my favorite GIF of all time. I love this one. So I get a new idea. It could be for an app. It could be for some new UI, some new pattern or something. Get super excited, and the first reflex, the first thing I want to do is just get home, open my laptop, and just start coding. I just want to like dump my idea, dump my brain into code as fast as possible to try and get a feel of the idea that I had in mind or the new UI and kind of quickly validate it. So I code as fast as I can. I get something that works. I play a few days with it. Sometimes it's great, sometimes it's not so great, but that's what it's for, right? You quickly prototype something to validate it, and I love doing that. The only problem with that is that, say the idea worked great, but you need to kind of go back on it and add something else or update it a little bit. And generally, when you look at your code after a hard session of prototyping like that, you're pretty sad. You're like, who wrote this? It's not a fun sight. And if you want to add a new feature on top of it, you're like, whoa. Like, basically, it's like a no-go. You either have to rewrite it or you kind of add more spaghetti to the spaghetti bowl. So this has happened a lot of times, and sometimes I even abandon little ideas because of this. And so I decided now that I have more experience on Android, I've been doing this for like 5-6 years now in several companies, that I needed a little change of mindset even for my own little projects. I needed to basically go from quick and dirty prototypes, which is what you always hear, to something more clean. And I wrote quick and clean prototype, and immediately you should think like, hold on, quick and clean? That doesn't work together, right? That doesn't go well together. Generally, you have one or the other. But after the experience I had on my day jobs, my professional experience, I started to think, well, what if there was a little framework that would help me for this, that would still make me write quick prototypes, quick apps very quickly to kind of test those ideas, but kind of have like more of a structure in my code. And so I started thinking, okay, what would that framework look like? What would I want? What would my perfect little prototyping, bootstrapping framework look like? So for the prototyping side, I want something that helps me write less code. As an engineer, we're all lazy. We want to write less code as possible, and it should still work. It should be easy to use. I don't want to go too complex, too deep, too over-engineering, because it's meant for doing something quickly, bootstrap something. But it should still be flexible so that I can build any of the crazy ideas I have. And for scaling for structure of the code, it should, of course, be layered, separating concerns between each components. The components should be independent enough that they can be swappable, replaceable, so nicely decoupled. And if they're swappable or replaceable, they're also reusable, which then reinforces the fact that you write less code because you're reusing stuff that you already built. And those components should be composable, so you can basically start from a little block and just kind of build on top of it and build something bigger. And that kind of reinforces the flexible aspect of it. So with all that thinking, I was like, well, this could actually work. Maybe I could make a little framework that's not too heavy to use, that helps me really do these prototypes quicker and have something clean at the end of the day, which I don't regret 2 days later. So I was like, let's do it. For once, I'm not going to make an app. I'm going to make a little library. I'm going to make a framework. And this is my first open source project, by the way, and I'm pretty excited about it. And what I came up with is a very lightweight framework that I call Helium. I call it Helium because it's so lightweight, it's lighter than air. And it's an MVP framework. Who's familiar with MVP, by the way? OK, so most people know what MVP stands for and what it is. I'll go really quickly in detail on that. And so it's a framework written entirely in Kotlin, because if you're doing a project, especially a side project, and you're not writing in Kotlin these days, you're doing it wrong. It uses the latest libraries that I like to use. It relies heavily on RxJava and uses one of the new or older architecture components, which is view model, which is, has some really nifty features which we'll touch in a minute. So here's how I like to introduce my library. I like to start with the end. This is a complete app in 20 lines of code. This app shows a list of 100 strings, in this case, that you can see here in the data. See if I can point here. No, I can't point. I'm not going to go into detail of everything. We're going to go slowly on each part. But the main idea is that if I want to write a little app like this that should display some data in a list, I don't want to write all the plumbing. I don't want to write the adapter, the layout that has a recycler view, possibly a loader, everything like that. All I want to write is the stuff that really matters, what data to get and how to display it. That's it. And that's what the framework is trying to achieve. So I'm pretty proud that I was able to fit a full app in one slide, by the way. This is like my little achievement for this presentation. So let's get into the detail of how it works. So as I mentioned, Helium uses the MVP framework. And it's roughly composed like this. There's 3 layers. I didn't want to have more layers than that. You could like break it down more. But again, I want to make this really approachable, really easy, meant for like quickly bootstrapping something. So this is the minimum, in my opinion, that you need to keep a structure more or less clean. You have a data layer. This is where your models live. This is where you typically will do your retrofit calls, API calls, database calls, etc. Caching layer will live out there as well. You have a presentation layer. That's where your behavior lives. This is where you actually define how your app or screen or component behaves. And there's very little Android codes in these 2 layers. And finally, there's the view layer. And that has most of the Android code that holds your views, your context, etc. So this is pretty classic MVP. And the approach I took for communicating between those layers is the following. Presenter holds a repository, so that's a pretty tight coupling there, because the presenter needs to know kind of which data to get, but it's the repository that's doing most of the heavy lifting. The presenter will just basically call methods on the repository at the right time. So that's pretty classic, and this is this is very flexible. You can do whatever you want there. What I did enforce, though, in the framework is that presenter and the view delegate don't know about each other. All they do is push objects and receive objects. So in the presenter case, you push state, and the view delegate renders that state. If you're a little bit familiar with the React model, there's a bit inspired by that. And the view delegate pushes events. So these are typically user actions, taps, scrolls, etc. And the presenter handles those events and decides which behavior to apply. So this is the main difference. They don't know about each other. They just push events, which allows really nice decoupling and maximum reusability. So the way they communicate is with these two objects, view state, view event. In the framework, these are just two empty interfaces. So for your state, you can have any object that you want as long as it implements the view state interface. The only requirement, and this is kind of softly enforced, but you should really, really, really do it, is that your state and events are both immutable. Once you push it, it's pushed. Nobody is allowed to touch it. It's final. This allows for much easier contract later on for stuff that we'll touch in a minute. So to reiterate, view state pushed by presenters, rendered by view delegates. The view state is typically your current view state. Like an example would be if you're loading something from the network, you're going to have different states, loading, ready, you can have error state, empty state, etc. This can be anything you want, really like free to imagination there. And for the view events, that represents usually a user action. So that's pushed by view delegates, handled by presenters, right? So there's this communication going there. So here's an example that I like to use for view state and view events. Since we're in Kotlin world, we can use some of the nice Kotlin features, such as silk classes. And silk classes work great for this. So here you can see it's really easy to reason what possible states I can be in when I encapsulate a silk class like that, and what possible events I can fire. What's nice about the silk classes is that the compiler knows already what all the possibilities that you can have. So when you use like when blocks or switch blocks in Java, there's no else or default. Like you already know all the possibilities, and that makes it really nice. But you don't have to use it. You can do your own object with a bunch of fields in it, as long as it's immutable. So let's talk about presenters. So as I mentioned, presenters hold your behavior. They're the big meat of your logic, really. They know what data to get, generally from a repository object. They know when to get it, because they know about lifecycle, and we'll look at that in a second. And they know how to react to view events to apply behavior. So since presenters push view state, not only they push it, but they also hold that state. And that's important because presenters can outlive your activity. Typically, when you rotate your activity and Android destroys, clears your view, recreates the activity, recreates a view, you can keep your presenter alive. And when you recreate that activity after rotation, you want to have the same state you left it in. So that's why the presenter holds that state, and the framework handles all that for you. We'll look at that. We'll look at how in a sec. And again, to reinforce, once you attach a presenter and a view delegate, the presenter starts receiving the view events from the view delegate. It starts knowing about lifecycle events, and that's leveraging the view model architecture component. And we'll look at how it does that. It's really nice. And it automatically cleans up all resources for you at the right time. You don't have to worry about any detaching, any cleanup, which again helps a lot when you're prototyping, but you don't want to like leave tons of leaks there for 2 days later to fix. So this is what a typical presenter looks like. So you extend the base presenter that's provided by the framework, and you define the 2 types, the state that you're going to push and the events that you're going to handle. Once you're in your presenter, you can do any method you want. So here, the typical thing, I load some data asynchronously from a repository. And on each step along the way, while I'm loading that data, I push the right state. Notice that I'm not doing any view. I'm not setting any loader to visible or anything like that. All I'm doing is pushing state. That method, load data, has an annotation there that is the view model. It was provided by the view model annotations. So base presenter extends view model. And what that does is that this method will be called every time the onResume lifecycle event happens. So you don't have to like override an onResume or onActive or anything like that. You just do your methods normally, and you annotate where it makes sense. I find it really nice, and it's just cleaner. And then the only method that you can override is onViewEvent to handle those user events whenever they come in. So now we find the same class that I defined before, myEvent. And I know that there's only 2 possible ones because it's a seal class, a click or a long press, and I can decide to do whatever I want from there. So that's a presenter. Now the view delegate, as I mentioned, this is where you're going to have your Android view logic. The real Android like framework code lives in there. And it's the class that will hold your context object. This is important to remember because context, we all know and love context, that massive God class that we have to kind of pass everywhere around. And the problem with context is that it's very easy to put it in the wrong place and leak everything. So it's important to remember that there should only be a context field in a view delegate because view delegates are throwable. They're going to be destroyed and recreated as your activity rotates, gets destroyed, stopped, etc. So it's OK to have it in there, but nowhere else, especially not in presenters, because presenters can be retained. And if you retain that, then you retain the previous activity, and it's going to be a giant mess. So view delegates render the state. They receive that from a presenter, and they push view events. That's all they do. It's a really simple class, and this is what it looks like. So again, you extend the base class from the framework. You have a couple of constructors. Here I'm using the one that you just pass a layout resource ID and an inflator, and it just inflates it for me. Really convenient. Again, you define which state you're going to render and which events you're going to push. That's kind of defining like which presenters it's going to be compatible with. Remember the chart. And once you're in there, you have access to the inflated view, which is this view field, and you can do your normal stuff, find views. Here I just have a button. I put a click listener on it. And again, here, no behavior logic. All I do is push an event, a click event. And someone will handle it, but I'm not putting logic here. The only real logic that lives in the view delegate is how I'm rendering the state. And again, because I define this object, here, remember the seal class, I can just do a really nice when statement, have all my states there, and write my rendering code. So this would be typically showing a loader, setting some data, or setting some text views, et cetera, et cetera. And it says really simple, really straightforward, and stays clean. So now I have a presenter in my view delegate. How do I kind of connect them together? So in your activity or your fragment, you would create your presenter, create the view delegate, and I have this attach method that kind of does the connection between the two. Once you're attached, presenter will start pushing states to that view delegate will start pushing view events to that presenter, and notice there's no cleanup code, there's nothing to manage behind this. It's all done under the hood for you. So that's all you need in your activity. And generally, that's all you need ever in your activity. You shouldn't have to have any more code than this. So I talked about retain presenters, and to retain it across configuration changes, you just have to change one line. Instead of creating a new instance of your presenter every time you create the activity, you go through this retain presenters get method, pass the class, and leveraging the view model architecture component, it will handle it for you and pass you the right instance of your presenter when you rotate. OK, cool. So we've seen how the library works. But what about that first example that I showed you, that nice little app in 20 lines of code? That was way more than 20 lines of code, right? So how did that work? Well, Helium adds another thing that I think is really useful, especially when you're prototyping, bootstrapping an app, is some ready-made components. If you've made more than one app in your life, like you realize that 90% of the time you're going to need some sort of list that loads some data from the network, for example. Why would you have to rewrite that every single time on every new project, right? So this was my first candidate to make a component for that anyone can reuse. And this is what I used in the first app that fits in a slide demo. So it comes with a view delegate. It comes with a base recycler item for your recycler item layouts. And I have also a pager one, because that's also one that we use almost every time in any app. And you just shouldn't have to rewrite it every time. Just saves you time. So these are great for bootstrapping, quick prototyping. And you can use them by themselves, or you can use them to compose your more complex presenters on top of it. So let's switch to a little bit of code. And this is the first time I do a live coding demo on stage, so bear with me here. We're going to build a really simple, quick app. And it shouldn't take more than 10 minutes, which is exactly what I hope for when I start a new app, or I want to do a new idea. So here I have a brand new project. So I have the empty main activity. I just added this class for convenience because we're going to build a little list that shows kind of a rainbowy color like this. So each item will have one color. And I created one layout, which is the list item that's just an empty layout with a height. And from there, so what I want to build is a recycler view that shows for each row a separate color, right? So first, let's think about the data layer. I could use as my model just the color, right, like the int. But generally, you should have some sort of model class that's pretty clean. So let's create one real quick. Let's call it my model. And it's going to contain just a int that's going to define the color, right? Then I need some sort of class, so a repository that will hold a list of them, because I'm going to show more than one in my app, right? So let's create my little repository. I'm going to call it my repo. And it's going to extend base repository that's provided in the framework. That's kind of really to help you prototype, but you should have your own implementation there. You don't have to extend that. You can do whatever you want. And it's going to provide a list of my models, right? So it wants me to implement something. So I'm going to implement it. It wants to implement the getData method, which is basically what data is going to be returned. So here I'm just going to generate a bunch of models. Let's say 100 of them. So I'm creating 100 ints, and then each int I'm mapping it to one of my models. And I need to pass it a color, and this is why I created my colors class, because here I'm just going to take one of the colors, actually not random, just following in the list. And then I'm going to aggregate that into a nice list. Okay? So I have my repo. Now, I don't want to care about how I create the recycler view, make a layout of that, etc. All I want to care about is what it's going to look like in each individual item. So let me create a recycler item. My recycler item is going to extend base recycler item. And here it requires to type it. It wants to know what type of model I'm going to display and what kind of events it might be pushing, because I might be having user interactions on this. For now, I'm just going to use the default interface. And the constructor for this requires, let me drink a little water here. The constructor requires a layout ID, which is the little layout I created. It's called list item. And it's going to require an inflator to actually inflate it, which I'll provide later. And it needs a container because it's in a list view, so it needs to know which container to add it in. So I'm just going to, this will get passed on later, I assume, by the framework, right? So I'm going to create a container, and this is a view group. And so let's see what it wants me to implement here. It wants me to implement the bind method, and it's passing me a model. So what did we say we wanted to do? Just show a color, right, on each item. So I'm going to take the view, which is the root of the recycler item, and set the background color. So here I'm going to do here. I want to pass is context compat get color. I can grab the context from the view, and the color is going to be inside my model, data.color. That's it. That's all the logic really I should have to write for this thing. Everything else is just kind of binding code, and that should be reduced to the minimum. So what do I need to actually display this? So remember the initial graph. So I need some sort of view delegate. So it's going to be my list view delegate. And that is the most handy class in the framework, in my opinion. It only requires the inflator, which we can get from the activity here. And it requires a little kind of a factory in the form of a lambda to generate recycler items for each row. So it's going to require a layout inflator and a container. That's what it's passing to me. And from there, I can just create my recycler item and my container. That's it. That's all the list view delegates actually requires. It will handle layouting the recycler view, creating the adapter, doing all this kind of plumbing code that I don't want to rewrite every time. That's kind of just boring. And then I'm going to need a presenter. So the presenter is the one that's going to load the data, and it's going to be a list presenter. This one I need to type. So it's going to be a list presenter. So it's going to be a list of models, my models. And it wants to know which type of events it might have to handle. And this requires only a repository, which I created. It's my repo. So this will call under the hood the getData method, load that thing asynchronously, et cetera, push the right state. And that all I have to do is just attach it to my view delegate. So here I could do some apply thing, but I'm going to keep it clean for you or readable, especially if people are not too familiar with Kotlin. So I have my variable here. Oh, and the last thing I need to do, of course, I don't want to set content view of the default hello world thing. I want to set content view of the root of my view delegate, which is just view delegate.view. Oh, I didn't even realize this, but could you read it properly? I guess it wasn't too bad. I was all prepared to do this, and I completely forgot. Is this better? That's probably better. Okay, so let's run this app. I have a little emulator here. And so how many lines of code do I have here? So I have a lot of space, but I have 47 lines roughly, 50 lines. But really, it took me 5 minutes to write this. And I have a great base for like an app that just displays the list, right? Here it would be really easy to, in the repository, to change it to like a retrofit call and do an actual API call that creates my models. And here it would be really easy to kind of just bind a real like full card view with images and everything. But everything in this part of the code doesn't change. So here you go. I have my simple little lists. And so this is great base, right? But you might think, okay, but like, how do I, for example, react to a click here? So typically you would say, oh yeah, I add a click listener right here. Click listener, set on click listener. And again, we should remember that in the view, we don't put any logic here, right? We just want to like push an event. So I have a method, it's called push event. That's part of the base recycler item. And here I can push any event I want. I didn't create one specifically, but the framework has one that is just like I use it all the time. I just created a click event that implements view event. And it requires a view, which I have, and whatever data I want to pass, which is my model here. Now, to make it a little bit more type safe, I can say that my base recycler item is going to only emit events of type myEvent, and each event is going to relay this data, my model. And you can see here that there's a type mismatch for the presenter. So you can already imagine that the list view delegate actually just like propagates whatever I define in my recycler item. But now my list presenter is like, hey, you said you only wanted to push click events, but for this presenter, you say it could be any view event, so that's not right. So in order to change this, let's just do our own little presenter to clean this up a little bit. Usually, by the way, I'm putting all these classes in here, but you would probably want to have separate files for this to keep it even cleaner. So we're just going to extend this here. And instead of view event, we're going to only handle events of type click event of my model, right? And then from here, you can just override on view events. Now it takes only a type click event and do something with it. So here I need to create my presenter, right? And so what should we do? Let's just do a toast. So we're going to just do a toast. I'm going to, for convenience, grab the context from the event. So notice, I don't want to keep any context in my presenter. If I need the context, I should receive it from an event that comes from the view delegate, but never hold on to it. So this is going to be my context. So now I can just do this, and we're going to show, I have a little method in my colors that just shows the hex of the color. So I need to do the context compat thing again. Okay, color, context. And in my event, I should have the data that was clicked. So that was in my model, which contains the color, right? So from here, I just need to pass the length, short, and then show. Let's run this again. So notice, no logic in here. It would be tempting to just put the toast here. But instead, you should always try to only do very simple just event pushing and handling the actual logic in the presenter. That's going to make your life way easier later. So now when I click, I get actually the hex of each color. Cool. OK, so everything works as expected. Now, let's do one more thing. Usually here, you would have some sort of API call in your repo, right? So let's pretend that this takes a little while. So we're going to delay it artificially by like 2 seconds. 10 minutes of seconds. And let's sort of run this. Let's see what happens if I delay the data and make it actually blocking. So it's going to run again. And now we see a nice little loader before my data comes in. I didn't have to do anything. And that's like something you usually are pretty lazy to do when you do a quick prototype. But it really adds something nice when you actually try to get a feel while you're building. And it's for free, so why not have it? So that's great. But now I mentioned, what happens when you actually rotate this? Oh, we load again every time we rotate, right? Because when I rotate, the activity gets destroyed and recreated. So it goes through here again. It creates a new presenter, which has no state. So remember how to retain. All I have to change here is just do retain presenters.get. And instead of creating a new one, so I pass the activity, I pass the class. So my presenter, class of Java. Now let's run this again. And let's see what happens here. It's going to run. So the first time I get my loader, right? Let's even, you know what, let's scroll down and see what happens when I'm in the middle of a scroll and just rotate here. It actually stays exactly where I left it, and it didn't reload. So what happened here? Thank you. What happened here? It went again through the onCreate code, but this time it already had an instance of the presenter, which had some state. That was the data I loaded from the repository. So as soon as I reattach a new view delegate, that one is brand new, it was able to immediately put the data there, the adapter, et cetera. And because it's immediately available, the view restoration just works and I stay in the same position. And that's pretty great to have like a clean base that now you can expand upon. So that's it for the demo. Let's see if I can quit this. Here you go. So hopefully it makes sense to you that this is not much longer to implement, but leaves you with a clean base that you can now build upon. And it actually took you probably less time than if you had to write all the adapter code and everything. So the library is on GitHub, obviously. It's all open source. It's still pretty early, but it's functional. And it's great for, say, a hackathon. I heard that you guys are doing a hackathon later. It's not meant for like a massive production app, at least not just yet. I really wanted to make this for kind of more personal projects to encourage people to just experiment and do something real quick and maybe put it out there. That's how I started Android, how I started my personal project journey. To illustrate a little bit more of a complex example, I made this little news app, which initially wanted to be my flying replacement, but there's so many news apps out there, it's hard to make something compelling. So I just used that as a really good example of how I could use this library and see if it worked. And it worked great. And the full source code of the news app is available on the repo. And there's also a link on Google Play that you can find on the GitHub page if you want to just download it and use it. I actually use it quite a bit. It's super minimalistic, super simple, but it's great. You choose your sources and you read the news. That's all I need. So what's next for Helium? I want to add more pre-built components. So as I'll build more of these, my ideas, my prototypes, my quick apps, or prototypes even for my companies, if there's something that I feel like would be useful for other people, I'm going to push it down in the library and make something kind of nice and accessible for the people to compose with. But of course, I can't just like add them all into one giant dependency. There's already quite too much dependencies in my opinion. So what I want to do is to break it down into multiple modules, especially like a core that will have minimal dependencies, and then probably like say a list one, pager one, could have like maybe a camera one, could have like some sort of like navigation one for button types, all the stuff that we have to do and redo on every single app. I just don't want to rewrite ever again. I want to write it once and reuse it. So if you want to use this library and you find you make a cool presenter or view delegate that you think would be useful, put up a PR and merge it, and you'll contribute to the beautiful Android community. That's what open source is all about. So with that, thank you all for listening till the end, and I'll take any questions you have.
Thank you, Joaquim. That's a pretty cool library that you can use. I'm kind of wondering, most of the time when you do MVP, you want to focus a little bit more on testing. I know that you didn't cover perhaps it's in the roadmap, but could you elaborate a little bit how does that look?
The testing of it?
Yeah.
So the nice thing about the framework is that these classes, they're your own, right? You can easily mock any dependencies that they have. You can unit test them individually. That's what I usually do. So typically, I could unit test this method really easily, right? For each event, I could verify that it does the right thing. I could unit test the render method in a view delegate as well. There's a few tests in the library. Oh, by the way, I forgot to show you. The only thing I added in the project, of course, is the dependency here. But I could show you the actual code. So let's say the list view delegate here has, so there's a bunch of configuration options because, again, you need to be flexible, right? So I don't want to like stop you from doing anything. So you can do crazy things like change the layout manager and everything. But for testing specifically, really the important thing to test is this render method, right? So you could assert, or rather verify that everything does what you expect here. And for presenters, which is arguably the more important thing you need to test, it's even easier. So this guy, for example, here is just like very simple, right? It does some refresh. That's really easy to test. All that is like super easy unit testable, rather. I actually have a unit test for all of these in the library that you can look at for inspiration. I should go back to this. Oh. Any other question?
How does the retained presenter work with like dependency injection?
Yeah, so actually, I think it's good that I show in code. Let's jump into the source here. So this is using the view model thing. I'm just wrapping it around really. And if you have this might be a bit hard to read, but if you had a presenter that has dependencies, you can actually provide a little factory that just you give the constructor here with all the dependencies. That said, if you're using Kotlin, it's actually pretty easy to just have all the dependencies in the constructor. And if you're using Dagger or anything like that, then it's just that inject and it's done. You don't have to do anything. Does that answer your question? I hate this presentation mode. There you go. So typically, if I wanted to have a custom constructor for my thing here, instead of giving the class, actually, yeah, no, I need to give the class as well. So can I do this? That's not great. But so instead, I would just provide a lambda here. And so it will give me a type of class here. It's just for type security. And here I can just create my presenter object right here. So here I could have any dependencies I want, you know, my tracker, my repository, my anything I want here. And it will still get nicely retained for me.
Test. The code is really elegant. Thank you for this. I have a really quick question on how your configuration changes work with the retained presenter.
Yeah.
Does it also apply to cases when Android kills your activity and the view state gets restored automatically with a new activity? Or did you do anything special to make this happen?
That's a really good question. I actually haven't tried this, but if it works with the view model, it should work with this because as you can see, it's just like, I just renamed this because I don't like the name view model. I like presenter because then it's very confusing what's in view layer, what's in presentation layer. But all I'm doing here is using the view model library behind, under the hood. And I'm pretty sure they restore, because it's basically the only thing they check for is when the activity gets created, if there's a saved instance bundle. And that's how they know if they should restore or recreate, right? And so I'm pretty sure it would work with the case you're talking about where your app is in the background for a while and gets recreated.
I think the view sort of restores its own state, like internally views.
Yeah. No, the views does. That's how the list kept the position on restore. I didn't do any special magic. Like the state didn't have like the last position or anything like that, right? So that's just the view restoring with the right timing. And that's important. Is that the adapter with all the data needs to be set at the moment when the restoration path actually happens, which is very early on.
Right. So, I mean, just to follow up on that, I think, the view restores itself. Android does it for you pretty much. But the data that could be out of sync. Let's say, for example, the view has like a checkbox or something. Would you have any sort of scheme by which you could essentially save the data? So let's say I checked a bunch of colors, right?
Yeah.
When the view restores itself, your internal variables for like, whatever you have in the repository doesn't automatically restore itself?
So if you have any state like that, say I have like position 135 checked, that's something you could have in your state. So basically, the way you would do that, you would probably send some events back up, say this is selected, this is selected, this is selected, and then you could have, some sort of like map or list or something in your presenter, and that will get retained, right? So that will get kind of pushed back down into a state object. So your state will contain what's selected, and then once it gets reattached, that last state will get pushed with position 135 selected, and the adapter will just do the right thing and just react to that selected state for each item. So it should work just fine. All right. Anything else? Are we good? Thank you so much.
Okay.